All right, so thanks, Shane, and thanks to all of you for tuning in. As Shane mentioned, my name is Tony Decicco, and I'm joined today by my colleague, Wael Nackasha, and today we're going to learn about generative AI, and with a focus on using generative AI to write and augment computer code. And before we dive in, we wanted to start with some brief introductions so you understand our perspectives on this. So we work in the artificial intelligence and computer code audit and due diligence groups at GTC Law Group, an IP boutique law firm based in the US. We've been fortunate to, on the one hand, represent several large Fortune 500 serial acquirers in the software and hardware space, as well as venture capitalists and PE firms. And on the other hand, we represent many startups to mid-sized companies. So along the ways, we've gained insight into the practices of, literally hundreds of organizations, including many creating and leveraging AI ML. So, overall, we're well positioned to understand the points we'll talk about today from, all sides of the table. My practice focuses on AI, open source, as many folks in the audience know, patent strategy and IP transactions. Well, can you tell us a little bit about your background?
Hello, everyone. Thank you, Tony, and thank you all for joining us today. A little bit about myself. Before starting my legal journey, I was a research scientist and programmer, and my primary focus was on an artificial intelligence product. I worked on recommendation system, face detection and recognition, continuous authentication, ECG signal recognition, just to name a few subjects that I worked on. In fact, the thesis of both my master's and PhD are based on machine learning. I eventually decided to become a lawyer and now working alongside Tony in the artificial intelligence and open source group. Most of the time you will see me wearing my lawyer hat, but sometimes I still put on my engineering hat. More as a hobby and just to give back to the community. I'm actually currently working on fine-tuning one of the available GPT models, and surprisingly, it looks so far a lot easier than I thought. If you don't know what GPT is, that's fine. You will know today.
Excellent. Thanks, Wael. So you can see here on this slide, these are the topics we plan to cover today. We have some Q&A time planned for the end. But if you have any questions that are better addressed in real time, I think you could drop them in the chat as we go. As you can see, there's a lot to cover here. There's a lot more we could cover, and we recognize that. So at the end or near the end of the webinar, we actually have a poll for everyone where you can vote on AI-related topics you'd like covered in future webinars. So I'll hand it over to Wael to get started with an introduction to GAI.
So this is a simplified and non-technical funnel represented as a Venn diagram that shows the path from artificial general intelligence to generative artificial intelligence, which is GAI. So what's AGI? Artificial General Intelligence, or AGI, it's a machine with intelligence that's on par with that of the human. So at the moment, it's just hypothetical, and it's sci-fi. Expert estimates range from years to centuries to have a real AGI. So the AGI machine can do what the humans do. It has the ability to perform a spectrum of cognitive abilities, such as perception, reasoning, problem solving, language understanding. It can learn and make decisions, has emotions and comprehension. I mean, think about the Terminator. We are not there yet, right? If you have heard of and likely used ChatGPT, and you may already think that ChatGPT can do all that, but actually it does not. Such systems don't understand language, but rather are based on statistical models. And then moving along the spectrum, the next concept is artificial intelligence. It is much narrower than AGI. It mimics human intelligence, but usually for a specific task in a specific situation or environment. Sometimes it even performs better than a human. We all know a lot of AI applications nowadays, such as like language translation, computer vision, autonomous driving, vehicles. These are just to name a few. And now we're going into deeper into that in the funnel, and it's machine learning. AI is often confused with ML or machine learning. ML is actually a method to achieve artificial intelligence, which is basically for a task. So AI is a broad concept, and machine learning is just one technique to achieve AI. So there are others, for example, logic programming or fuzzy logic. But machine learning has been gaining a lot of interest, mainly because first it requires computational power resources and data, and now we have both. Both have been advanced greatly over the recent years. So compare your computer speed or storage now and 20 years ago, or compare how many photos per month you take now versus 20 years ago. So yeah. So what's machine learning? Machine learning applications usually have algorithm, models, and training data, at least. And then, for example, when we say training data, it could be images, it could be text, could be just numbers that's specific for the task. For example, if the task is to identify humans from their faces, the training data set is usually human faces of different people. Even better, it could have different traces. If the task is to predict the amount of rainfall in an area, then the training data could be the past rainfall numbers in that area. So machine learning algorithm builds a model. So now we finished with the training data. Now the algorithm. The algorithm builds a model based on the training data. And then this model can be used to make predictions and decisions based on what these machine algorithms saw in the training data. So basically, the model relies heavily on the data set for training. That's for machine learning. And now we go even deeper, which is deep learning. Scientists have realized that now we have a lot of data, but the performance of machine learning started to plateau. So we weren't making use of the extra data we have access to, even though we have a lot of computational resources. So deep learning algorithms were developed. They make use of the abundance of data we have access to now. So therefore, deep learning is basically a class of machine learning algorithm, and it uses multiple layers. Or you can think about multiple layers as multiple stages of processing. The more the layer, the more complex the model is, and the more training data you need, and the more processing power you need. When we go to the term why it's called deep, it's basically is how deep it requires multiple or deeper layers to perform the task. And deep learning is usually used, what probably you've heard of, the term neural networks. It's some type of machine. A neural network simulates how the human brain operates. They're comprised of connected nodes, and they try to propagate data from the input to the output. So it has multiple stages, such as input, hidden, and output stage, or layers they call them, and then propagate the data through these layers in order to achieve the desired task. So after that, now we get to GAI, or Generative Artificial Intelligence, which you hear about in the news every day, given all the recent advances in this area. So GAI is a set of deep learning methods that are capable of generating data, such as text, images, videos, and software code in response to prompts. It requires a lot of training data of computational resources. Some sources say it requires all the data on the internet, and that's causing a lot of problems. Now we go to some GAI applications. We'll work through some examples now, and this is definitely not an exhaustive list, and new applications are surfacing almost every day. So some applications generate text, which generates text from text input. It could be used for generating email content or chatbot to answer questions, writing an essay or blog, or writing content for a website. And we know an example is ChatGPT. It could generate images, which this creates images typically based on input text prompts. And these images are basically photorealistic qualities, and you'll see some examples as well. It could be used to generate code, which creates computer code from text input. And not only code, but it could use also for code augmentation, like generating code comments and testing the code. It's actually in our line of work, this is picking up greatly, and we have helped many clients put in place code generation and augmentation policies just in the recent months. Another application, it's video. It generates video. It basically turns it turns narrative that you have into videos as somebody speaking it. Music, it generates music from text. And another example which I like is synthetic data generation. Sometimes data is scarce or very hard to collect. So you can use GAI to generate a data set which you can use which can use then for training other models. For example of scarce data is medical data. It's actually worth noting that these applications are generally not new, and they did exist prior to the recent advancement in GAI, but their performance is much better now with GAI. For example, my training dataset for my PhD dissertation includes recognizing people from their ECG signal. So the training data was ECG signals. I didn't have enough ECG signals, and I needed to train my model. These signals are just hard to collect and must undergo very strict policies and privacy protocol. So one of the methods that I proposed was to generate synthetic ECG signals and then just use them. So it did exist from before. Now let's go on to a quick demo for generating some text and for generating some images using ChatGPT and DALL-E. So here are the landing page for the web version of ChatGPT and DALL-E, and they both expect a text prompt. For ChatGPT, we prompted it with what is generative AI. For DALL-E, we prompted with just provide us with oil painting of a blue house with a red door on a grassy hill in the style of Vincent van Gogh. And you can see in both cases the result is decent. And then after that, you can reiterate and you can iterate and refining the prompt that you have to have different results. Now, in the next set of slides, we'll introduce a very simple machine learning example to explain some components we use in this presentation. Basically, traditional coding works by defining rules for the computer, right? And for it, the output is usually deterministic, and it's the same every time. A different approach is to use machine learning, the output of which could be based on a statistical model that could change. So this is a super simplified example that comes from one of the foundational pattern recognition textbooks. In this example, we have a fish packaging plant that automates the process of sorting incoming fish on a conveyor belt based on species. The fish are sea bass and salmon, and the task is to separate the fish automatically based on the camera input. Just to emphasize, of course, this is not a crash course on machine learning, but the main point here is hopefully to make you appreciate how big and sophisticated those GAI models are. So you have training data, right? Which is, in this case, a pool of data, which is a lot of sea bass and salmon fish photos. And you need to generate a model that can be used so that you give it a fish image, and it tells you if it is for sea bass or salmon. Some images in the data set may be of bad quality. So what you need to do now, you need to pre-process the data to basically clean it up. For example, correcting some photos that aren't clear, fixing contrast, and removing bad data. Then what you need to do, you need to extract features. The algorithms cannot understand the content of a fish image. The image is literally a set of pixels, and each pixel is represented by a number or more that is displayed as color. These numbers are all what the computer sees. So we may need to extract feature, like in this case, width and lightness of the fish from each image, and then try to classify the fish based on these features. Someone else might choose different type of features. For example, the pixel colors. So in this example, this is a supervised learning, which means that we tell the algorithm that each of the training data is a sea bass or salmon. As we see here, as orange and black circles. Then the machine learning systems builds a model. Here on the left is a line function to classify the fish, and the model can be used on new images. So if we see on the left side, so this is the model that we generated, is a very simple model. But just being a line in this example, you see the performance is decent. It could split the sea bass and salmon fish. There are some errors, of course, but still based on this very simple model. And to make the decision, the computer will extract features from an incoming image and see where it lies. If it is, so basically, we provide the computer with images that it didn't see before. It's not from the pool of data. And then we ask the computer, based on this model, where would this point lie? So the computer would say, if it lies on the right side of the model, then it will be classified as sea bass. If it lies on the left side of the model, it will be classified as salmon. And of course, this is a very simple example. Instead of this simple example, it could be much more complicated, like, for example, the one on the right. Then again, so the prior example was what's called supervised learning. Supervised learning. We provided the input. We said this is sea bass and this is salmon. You can also have unsupervised learning, like what we have on this slide. Here, the data doesn't include whether the image is of a sea bass or salmon. Instead, we tell the algorithm to split the data into two clusters. And when this model, and so once it's split it, we have two models cluster for each data that is split. And then we store that model. And then once we get an incoming image, we provide that image to the model, the machine check which cluster the incoming fish image belongs in, and decides if it's sea bass or salmon. So there are many other approaches. These are just, we gave two approaches, unsupervised and supervised. There's just simple examples, but there are many other approaches like semi-supervised learning, reinforcement learning, and others. There are some takeaways from these examples. Number one, as you may have noticed, that machine learning components, they work in synergy. Data is key. Really, the competitive advantage comes from the data, and if you have better data, you can build a better model. And you need large volumes of data to increase the accuracy of the model. That's why there is this term that's garbage in, garbage out is used. It's coined, and then you use it. If you have bad data, you get bad output. But that's not the only thing. The other thing is, if you have bad algorithm, they will equally generate a bad model. Even though the data is good, it's clean, still, if you have bad model, you will get bad results. That's number one. Number two, if you take, let's say, as simple as this clustering example or the one before it, this one has two features only, which is the lightness and width, right? And the model is basically a circle which could be represented by a couple of parameters. Or even if we go to the one before it, we have a line which could also be represented by a couple of parameters. We also have features of two. If you compare these simple models, they performed okay. You have a good results in there. There are errors, of course. But if you compare this to GPT, right, what we have now, it has the same concept: training data, pre-processing, feature extraction. But here's if you compare. So we have this, instead of the two features that we have, GPT extracts 2,048 features, right? So you can compare how complicated it is. And instead of representing the model by a couple of parameters, GPT uses 175 billion parameters. So imagine how much data you need to generate such a big model. It's just, again, some sources say that they think that just all the text on the internet was needed to generate that GPT model. And now back to you, Tony.
Great. Thanks, Wael. So now we're going to turn to using GAI to write, test, and improve software code. So in our experience, the developers really want to use these tools, and they're often met with risk managers, including lawyers, who are trying to get their arms around the technology to protect their organization from, unnecessary risk. And they're generally fielding many questions, some of which they don't yet have answers, and they're, outside their comfort zone. As an aside, we should mention we created the images on this slide using DALL-E 2. Help with this. So we'll jump to the next slide now, and we'll start with some background on what this class of tools can do. So, over time in our work creating the relevant policies for many companies, as Wael mentioned, we came to divide the functionality into code generation and code augmentation. So by code generation, we mean sort of creating new code or modifying existing code. And then for us, code augmentation covers, augmenting or editing materials related to software code, such as documentation, code comments, QA scripts. And as for the tools themselves, like the common ones, in our experience, GitHub Copilot is currently, the most widely used tool we're seeing for code generation. We're going to take a deeper dive into Copilot in a few minutes. And we also see Amazon Code Whisperer gaining traction. And then on the code augmentation side, while these two tools can augment code, Copilot can do it, Code Whisperer can do it. It seems like GPT-4 is sort of the developer favorite. And there are many more tools, out there beside these, including, very well fitting for the OpenChain audience, open source tools. There's one called Faux Pilot. So that's FAUX Pilot. It's released under an MIT style license and is described as, an alternative to GitHub Copilot. So now we'll do our deeper dive into GitHub Copilot. Copilot's a generative AI software development tool that helps a developer write code faster by attempting to understand the context of a programmer's code or comments. So basically, guesses the programmer's intent, and then it suggests code options. It was released in beta form in 2021, and then it was released as a commercial product last year. And as you likely know, Microsoft now owns GitHub and is, the primary driver behind GitHub Copilot. And you've probably seen in recent months or the last month, Microsoft's released a whole bunch of other tools they're calling copilots, for, Teams, for Word. So today we're just going to focus on GitHub Copilot. And then Copilot is integrated as an extension, right into the developer's IDE. So if it could be Visual Studio or JetBrains, and then this IDE extension sends the developer's code and comments to the GitHub Copilot service, and then that service uses the OpenAI codex to synthesize and suggest individual lines of code or even entire functions, which are then sent back to the IDE extension and displayed to the developer. The OpenAI codex itself is a deep learning model, as Wael mentioned before, and it can handle both natural language and code. As far as we know, the model was trained on English language content and publicly available source code, including, interestingly, GitHub public repositories. So this training process, used large volumes of English language content, and as we'll talk about later, key for today, large volumes of source code. And this source code would have been copied, likely annotated or modified in some way to condition the data, or in legal speak, probably creating a derivative of the code. And then it was used to train the model. So we'll do a brief, demo in air quotes here of Copilot for generating some code. It's just really a screenshot demo. And here we're going to use natural language to generate code. So the first image there is Copilot in the Visual Studio IDE, and we included a comment that we need a function to convert Celsius temperatures to Fahrenheit. And then in the second image, you can see, once we start defining the function, so here it's in Python, and we're using the syntax, def, to define it. Copilot starts to suggest the code in gray there. And then in the third image, we actually accept the code. So note that the code doesn't have any comments. There's no license information. There's no indication of where it was possibly taken from or what it was possibly based on. We don't know whether it's a snippet extracted from a bigger project or a standalone function. So from a risk management point of view, this could need some extra scrutiny, and we'll discuss that in a few minutes. And then we could also use Copilot to add comments to the code, but we thought it would be good, to show you all how GPT-4 could be used for code augmentation. So jumping to the next slide, we accessed GPT-4 through Perplexity. It's an interactive AI search companion that leverages GPT-4. On the left, you can see we first had the prompt to ask what the code does. So we pasted the code in, but we didn't copy the comment we had on the top saying it was to generate code from Celsius to Fahrenheit, since that would be, too easy for the tool to do. And then GPT-4 generated the output that's there on the slide, basically saying this code is Python code. It takes temperature in Celsius as input from a user, it converts it to Fahrenheit, and then the output from the tool here even includes the mathematical function needed for computing the conversion. On the right, we gave it another prompt, and we asked it to add comments to the code. This type of documentation is a crucial step, but as many in the audience know, most programmers don't like to do it. So you can see that step is nicely and correctly commented on the slide here. So it's pretty interesting and powerful tools. So it's interesting to think about what have the community reactions been, mainly in the developer community, to all of this. So overall, most reactions from the developer community have been positive, noting support for multiple programming languages, increased productivity and creativity. Copilot can often offer unconventional or efficient suggestions that can simply be accepted. And I'd say overall, there was like a sigh of relief that Copilot won't be replacing developers anytime soon. There have been some negative comments too, and they're founded. They focus on confidentiality concerns. You're sending your code to the Copilot service. As we'll talk about in a bit, there's settings you can configure, to not have the models learn from your inputs or outputs. And for certain tools, you can even prevent any human review, but it's still a fair concern that you're sending some of your code to another party. I would say, although most companies have their code in GitHub, already, there's risk of infringement, including copyright and copyleft violations with respect to the code and, code augmentation. And we'll discuss that in a few minutes. There's issues around code quality. Copilot's FAQ itself says the code it suggests may not always work or even make sense. Code suggested by GitHub Copilot should be carefully tested, reviewed, and vetted like any other code. I'd also say, the same applies to code generated by people. So, there's an incremental risk here because there's higher volume and it's coming from somewhere else. But, it's similar concern for human generated code. There was some concern around security. So the generated code might not be secure. There's another dimension to this too, like Copilot may suggest code that by itself doesn't have a vulnerability, but when the vulnerability might be introduced when you start, having multiple suggested snippets put together, or you combine that code with your code. But again, the same, applies to code generated by people. The final one is interesting. It's around morality. And it's been mirrored with respect to GAI tools more generally. There's been a big movement by a lot of authors, wanting, compensation for their works being used to train all these tools. So here, Copilot uses public free code to basically create a for-profit product. The Free Software Foundation, weighed in, and it considers it a settled question that, in their view, Copilot is, quote, unacceptable and unjust. So there's a lot of, reactions from the community. So, is this all overblown? Are these concerns overblown? So here's some context. Copilot could do things like on this slide. So in this example, Tim Davis, a well-known computer science professor at Texas A&M University, shows that Copilot's generated code on the right is almost identical to his code on the left. So his code is subject to the LGPL. However, the generated code doesn't mention any license covering the code. As a reminder, and I know this audience knows this well, the LGPL is a copyleft license, and depending on the usage of the code, could require other, possibly commercial code to be made available in source code form under the LGPL. The LGPL also has notice and attribution obligations. So in this case, as a Copilot user, you wouldn't know any of that, but the requirements could still apply to you. It's also interesting in this case, Professor Davis even had the feature of Copilot that is to avoid displaying publicly available code turned on, yet it still generated this code. So it was supposed to filter out any code that matches publicly available code, and it didn't work in this case. In addition, this also means that Copilot was likely trained on Professor Davis's code. Otherwise it wouldn't be in the training set. So we'll jump to the next, to this slide. So, given Copilot does things like that we just saw, you get things like this, lawsuits against GitHub Copilot. So, since GitHub Copilot doesn't suggest the licenses, or it could suggest the wrong license and it can have incorrect attribution, some parties filed lawsuits, class action lawsuits against GitHub, Microsoft, and OpenAI. And basically, the suits are for software piracy. The class actions were filed back in November. There were 2 of them. They were filed in U.S. federal court in San Francisco. The 2 class actions have been consolidated for purposes of discovery and motion practice. And these were likely the first class actions, at least in the US, challenging the training and output of AI systems. And since these suits were filed, Sarah Silverman and a couple other authors filed another proposed class action lawsuit against OpenAI, alleging that their copyrighted books were used to train ChatGPT without their consent, without credit, and without compensation. It's interesting to note it's the same lawyers bringing that class action suit as this one we're going to talk about. There were also 2 more class actions filed against OpenAI and Microsoft relating to ChatGPT and DALL-E. They have similar claims that we'll talk about here, but interestingly, one of the plaintiffs is a minor, a 6-year-old, who used the microphone feature to ask ChatGPT questions. And there's also a similar class action against Google in respect of Bard, and it reads very similarly, because like I said, I think some of the same lawyers are behind these suits. And we're looking forward, to how these cases will unfold. They're going to form up the law here. So we'll dive into the issues here on the Microsoft Copilot class action. So it's alleged that Microsoft Copilot ignores, violates, and even removes the licenses offered by thousands or possibly millions of software developers. So GitHub Copilot could be committing software piracy on an unprecedented scale. Further, the lawsuits claim that the defendants have failed to comply with the licenses attached to much of the training data, and instead they've really just pretended that those licenses don't exist. It's also not clear how the training data was collected. They could have used web scraping, which some of the claims allege. And the lawsuit against the defendants here, actually, we quoted on the slide, says the defendants have been cagey on the source of the training data. And we know Microsoft has direct access to GitHub because they own it. So they probably didn't need to scrape the data, actually. They could probably have done it on the back end. So we'll turn to a couple of the claims from the suit, and we'll cover, 3 of them. And the case right now, is making its way through court. There've been several motions, amendments. I think it's going to be a while before the 2 sides kind of settle and agree on what they're actually going to pursue in court and sort of proceed to the substance. Everything right now is a lot of procedural aspects, but the claims mainly revolve around software piracy. So we'll dive in on 3 of them. So the first is that the removal of the copyright notices and the license information is a violation of the DMCA. Along with distributing copies while you're knowing or you're intending that the copyright information has been removed or altered, without authority of the copyright holder. So you can't remove a copyright notice, and you can't do it, definitely can't do it unknowingly or intentionally. So that's the basis of that claim, because there's no notices or license information. The second is that the open source licenses themselves have been violated. For example, Copilot, as we've seen, has been found to reproduce verbatim snippets of open source code. including code under the GPL and LGPL. But Copilot doesn't pass along any copyright statements, doesn't pass along the applicable licenses for these snippets, as required by the licenses. And the third is another interesting one. The third is that OpenAI and Microsoft have breached the actual GitHub terms of service. So like that link at the bottom of a GitHub page that links to the contract, the terms of service, it's alleged that Microsoft has violated, those terms themselves. So the GitHub terms themselves wouldn't allow the data to be used for training a machine learning model. We did an interesting exercise. We actually used the Internet Archive to compare the GitHub terms of service before Microsoft bought GitHub to after Microsoft bought GitHub. And interestingly, some key terms were changed. So before the acquisition, there was a rights grant from the user to grant GitHub the rights to store, archive, parse, and display the publicly posted content, and to make incidental copies as necessary to provide the service, the GitHub service. But after the acquisition, the terms were revised to add that providing the service also includes improving the service over time. So that that improved Microsoft's position here, since Copilot's a new feature. So they're going to argue they were allowed to use all the content posted in GitHub to improve the service, which means improving this new feature to have GitHub Copilot. So overall, it's going to be interesting to watch how these cases unfold, as well as sort of the broader issues regarding GAI, especially as applied to developing code. So now let's jump to some of like the risks here associated with, particularly with using GAI to generate and augment code. So we're kind of in our domain of code. We're not going to talk about images and other content. We're going to focus on code. And I want to start by saying, like, this slide lists many possible applicable risks. Not all of them are material in all situations. In fact, I think some of them are pretty remote. Depending on how you're using the GAI tool. And as we'll see, there are many ways to mitigate these risks, and the benefits largely outweigh the risks, once the mitigations are in place. So the message is, like, it's not that you cannot use these tools, it's that there are risks, but we can address them if we're smart about it. And a lot of this, I find, echoes the discussion around open source 10 to 15 years ago, when companies were still saying you can't use it. And eventually they realized you can't be competitive if you're not using it. And I think the same, is going to happen here. So the first area we'll look at is copyright. So as we saw, GAI can generate text or code snippets, short fragments of code that are identical or substantially similar to the material it was trained on. So this means it could put code or other copyrightable content into your product that's identical to a copyrighted work owned by someone else. So that could result in copyright infringement. The next one are the licenses. So it's also possible that that copyrighted work that's now in your code was made available pursuant to a license agreement, open source or otherwise. And then the GAI tools here do not provide notice and attribution of the relevant licenses. So you would not even know that a license applies to that content. So as a result, you could breach the license terms. The next is notice and attribution. So as we know, in the case of open source, almost all the licenses require notice and attribution. That's to tell your downstream recipients, like your customers, that you use the open source code, and you got to give, credit where credit is due. But if you don't know about the license, or even that you have code matching the open source code, you're not going to comply with any applicable notice and attribution obligations. The next one is, conflicts or incompatibilities. This is sort of typically a lesser issue, but as we know, some open source licenses aren't compatible with each other. So this means you can't mix code that's under those licenses. So in the case of GAI generated code, you may not know the licenses, so you can't be on the lookout for these incompatibilities or conflicts. A more common issue, though, is that the open source license might not be compatible with commercial software, depending on how the component's being used. For example, code under a strong copyleft license like the AGPL is often not compatible with commercial software use. But if you don't know the licenses, or even that the code may be identical to the open source, you can't be on the lookout for this risk. Another interesting risk is around patents, and people aren't, really focused on this, but, it's possible that the generated code could infringe a third-party patent. Perhaps the code even comes from a patent filing that was in the training data set. We believe that, all published patent applications, at least in English, and patent filings, including patents, were in the training data set. This seems like a pretty remote risk to me. But it's interesting to flip sort of the patent and copyright issues around and consider them from the perspective of trying to seek patent or copyright protection. So for example, at least in the US under current law and approaches, code generated by GAI is very likely not copyrightable. And then inventions generated by GAI are also very likely not patentable. So you have to be very careful, how you deploy the GAI for code generation, because you don't want it to generate like secret sauce code that you'd want to own, or to possibly end up inventing things that you want to patent. Security, we talked about that earlier. There can be security vulnerabilities in the generated code. They can be in the generated code itself, or they might result, from combination of the generated code with other code, both human code and other generated code by GAI. Confidentiality, use of the tools involves disclosure of proprietary information, trade secrets, confidential information. You're actually, sending aspects of your source code for which many companies are the crown jewels to a GAI service. So you also need to consider whether this could be a, disclosure for patent bar date purposes. Again, I think that's a much lesser consideration than the core confidentiality concern. Privacy issues is not one that people typically think of with respect to GAI generated code, but there could be disclosure of personal information in certain circumstances, possibly in the code comments or in the content the GAI tools suggest. Quality is a big one. We heard from Microsoft earlier when I read from their FAQ, like the generated code or content may be of lower quality. It might be incorrect or it might be unprofessional. Bias is another important one. And again, you don't hear about this as much in the context of code, but the generated code and content might be biased or discriminatory. Unfortunately, the code comments in the training set are sometimes biased and discriminatory. So it's only reasonable to expect that the generated code comments based on that data, may be too. Insufficient rights. There may be insufficient rights in the training data, which may lead to litigation or having to destroy the code. I think this is also pretty remote, since most of the litigation would likely focus on the provider of the GAI tool and not the users. And this has been the case in all the lawsuits so far. The last one I'll mention is policy violations. So you likely have, depending on the size of your organization, other policies in your company, like anti-discrimination, anti-harassment. You probably have coding guidelines, depending on the size of your dev team. So the generated content may violate these company policies if we don't, plan for it. So we'll talk about the mitigation strategies next and sort of how you can, address all these risks. Like, as I mentioned, I think they're all largely, surmountable. You just have to, plan for them. So the first thing I'll talk about are software composition analysis, like code scan tools. So if you're using GAI tools to generate and augment code, and even in the absence of using GAI tools, you should strongly consider, using software composition analysis scanning tools. As we all know, there's tools that function basically as a large plagiarism detection, correlation engine for code. They scan the code, they identify blocks of code that match existing open source code, and they let you know the license applicable to that code. In the context of GAI generated code, SCA tool will allow you to determine if the generated code matches existing code out there and if there's a license. And we saw, that the stock functionality might not work, and GAI tools can often generate code snippets. So I'd say it's important to pick an SCA tool that can match at a snippet level, not just a package level, because it's rare that the GAI tool is going to suggest an entire package. And then you also need to consider, whether the scan should be performed each time a GAI tool is used, or just follow a more regular cadence, used by the company already. Maybe it's your build cycle or your release cycle. And of course, you need to have a process for reviewing and complying with the results of the scan. The next area is security scanning tools. So, as with the SCA tools, you should perform, security and vulnerability scanning on your code, even if you're not using GAI. There's many tools out there, and you should consider tooling for scanning for vulnerabilities on a snippet level. There are some that do that, not just on a package level. Again, just given the propensity here for code snippets. And you have to set your cadence of scanning, just like we talked about for the SCA tools. If the generated code should be scanned any more frequently, or you're just going to do it at the same rate you scan your human created code. And you need to have a process again for reviewing and acting on the results. Next one's obvious, human review. I think it's the most important review.
but it can definitely be labor intensive, time consuming, costly. So it needs to be deployed with real purpose. And human review can include review against your company policies. It can include review by engineering or other developers, like peer code review, which is often used outside the GAI context. I'd say you can do it in the same way that you would subject a junior developer's code to peer review. You do the same thing for the GAI code, and you can also review for code quality, compliance with the coding practices of your company. There can even be legal review. It can include things like acting upon and addressing the results of the SCA scan, to minimize the likelihood of license breach or copyright infringement. The legal review can include, reviewing proprietary data, code, or content actually submitted to the tooling. And I'd recommend you do this like on a categorical basis, like by type of code we'll talk about. For example, like infrastructure code can be shared with the GAI tool, but maybe your core business algorithm code can't. In some cases, like the legal review may involve considering like downstream customer agreements. In certain cases, you might not actually be permitted to use a GAI tool. If you're creating like a professional services deliverable, we've seen some contracts, actually prohibiting the use of GAI tools or any AI tools without the customer, agreeing. As an aside on the human review, you can see on the slide here an image created by Stable Diffusion. It's for the prompt, human reviewing GitHub Copilot code. We're surprised by the output. It's pretty accurate. If you look at the screen there, you can see it has some sort of IDE that's there. I also say, maybe some of the bias is present because if you look at the programmer, it's a male, the particular profile that is also probably present in the training data set. We'll jump now to some of the GAI tooling safety features themselves. So when you get the tool, it's important to like properly configure it and leverage the features that the vendor makes available. There's some examples like you can enable encryption, you can configure the tool so it doesn't retain your code, you can configure it so it doesn't learn from and is not trained on your inputs to the tool or the results it provides to you. You can even turn off the human review. Sometimes you want to keep it on because they have abuse monitoring on a lot of these tools that can involve escalating to a human, but you can also turn that off and make it, maybe it's better for you that, no human has access to your code. There's also, some structural things you can do here. I won't go into them in a lot of detail, but, we were kind of reimagining these tools. If you could imagine a version of Copilot trained on a corpus for a particular company, maybe it's permissive code or code with consent from the developers or the code that's already in the company's code base, over time. So it's sort of trained, on a walled garden, type of approach. But overall, it's important to address these issues through these mitigations. So it sort of brings us to our next topic of policies and procedures. Like I'd say it's a really good idea to put these in place if you're going to leverage the GAI tools, especially for generating and augmenting, code. So the last topic for today before our poll will just be a little bit on these policies and procedures. So here's another cool Stable Diffusion output. You can see the policy there for using robots. So in our experience, and we've done, many of these this year, it's been a pretty hot topic. A policy for using the GAI tools for code gen and augmentation should be short. It's really no more than a few pages. Otherwise, just like an open source policy, it won't be followed. And then given that we're talking about source code, it's important to limit the GAI tooling itself to like the enterprise grade tools that are pre-approved by the company, and the users shouldn't be able, or at least they shouldn't be allowed to change the settings on the tools. So I would avoid, most of the free tools because they don't have the same protections and ability, by and large, to turn off the fact that it'll use your code for training. And then we found like the best approach is to come up with some common usage categories or use cases that apply to your company, and then try to line those up with all the mitigations we discussed, and then use those categories and sort of calibrate the whole thing based on the risk level. So, what do I mean by that more concretely? So some of the common use cases we see are like mission critical code. So code that's distributed or hosted, or it's central to your solution and it has your secret sauce or your crown jewels. And then there can be a category of like ancillary code. So it's not mission critical code, but it's something that's distributed or hosted and includes functionality that's like not essential, or it's like infrastructure or like platform related code. And then another common category is internal use code. So it's not mission critical, it's not ancillary, and it's only used internally in the company, without any distribution, no hosting. So it could be stuff like unit test code, test stub, QA code, things like that. So then with these use cases, the mission critical code is likely higher risk and more important than the ancillary code, which is more important than the internal use code. So maybe your policy, is to allow the GAI tooling with sort of the for use with the mission critical tool, like for the, it's to not allow it, sorry, for the mission critical code, although we have ways and many clients who do allow it. But for this example, let's say you decided not to allow it for that, but then you allow it for the ancillary and internal use code. And then maybe you do SCA scanning for this ancillary code, but you don't actually do SCA scanning on the internal use code. And then you subject the whole of all the code to security testing. And you can literally like develop a table, with the use cases across the top and the mitigations down here, and you can have check X or maybe, and you can populate the table of mitigations on what you're going to do for every use case. I'll say too, it's common these days to see a sandbox environment that's largely a free-for-all. So there's no rules that really apply to it, but the developers, they can't take the code out of the sandbox because then all the rules are going to apply. And companies like this right now, so they're kind of figuring out how they're going to use the tools because they might not know enough yet, to write their policies. So, we covered a lot there. We're going to open it up for questions in a minute, but first we're going to jump to the poll here, and I'll talk about it for a minute and then we'll put it up. The idea here is these are future webinar topics, we're happy to come back and cover. They range from sort of a deeper dive on the legal considerations. We haven't really talked about fair use, which I think is going to be the defense to a lot of this. We haven't really dove in on web scraping. There's a lot of laws and regulations out there, especially in the EU, applicable to AI tech. There's also other lawsuits, like I mentioned, not just the one on Copilot. If you guys are data scientists and you're trying to, use training data, there's a lot of hurdles to overcome, around that to like get rights in the data set. You need to do the training, and, sometimes open source licenses are applied to the training data. So there's some best practices around that. There's also, intersections between AI and open source. Like I know this audience is very, open source savvy. So some of the open source licenses actually apply to the models themselves, and there's shortcomings to that. And there's also, open source style licenses that are specific to this area. We can cover. They might not, satisfy the OSI definition exactly, but they're in the ballpark. There's also interesting concepts around contracting. So your agreements, when you're licensing AI tech to customers, and also when you're licensing AI technologies from vendors, into your organization. If you're doing government contracting, there's a bunch around just the government procurement regs that we can talk about. There's issues around AI governance and, board reporting, AI risk management, including, the risk management frameworks, bias and discrimination, like we talked about. There's, laws on this in New York. For example, California has one coming out. Sustainability is another topic we often talk about. Like all this technology consumes a great deal of resources, and I think there's also going to be a text field in the poll where you can sort of enter in other topics. So let's try to get the poll up now, because I think Shane might have had to drop. So let me see if we can get this poll up here. So I'm going to put it up here, and while you all can respond to the poll, we will go over some of the questions that have come in here. So I'm just going to sort of catch up on the chat and see what we have here. Okay, so let the poll run. If there's any questions on that, just let us know. If you think of other topics too after the webinar, we've included a couple slides at the end. I think the deck will be made available to have our email addresses. If you Google us, it's pretty easy to find us at GTC Law Group, and we're happy to consider other topics too. Okay, so we got a question here. Let's see here. So here's a question. As far as I know, With the general applicable law, copyright protects the expression. When creating a model with ML, the data is torn down into pieces and can be consumed as particles that cannot be copyrightable. But how can copyright holders, claim for their rights? Would there be a difference if the data is open source software and pictures posted on the web? So it's a really good question. I think it's core to some of the cases. So I actually think you are tearing down the data, but there's a couple upstream sets of rights too. Like you have to, first of all, have rights to even possess a copy of the data. So you need to make a copy of it. And often you don't even have rights to do that. And then you need to have rights to condition the data, to make a derivative work of the data. So even if you don't retain the data in the model you created, you still infringe rights probably in the process of using the data, to create your model. And then I think it also depends on the model itself. We've done work for clients, opinion work, in fact, where we've sort of looked at, is our model derivative of the data? And there's things you can do to make the answer to that question, no, or more likely to be no. But sometimes the model is derivative of the data. If it's just like a map of the data and you can, reconstruct some of the data from the model. So it's not always the case that they're sort of torn down and there's these particles that can't be copyrighted. You can sort of regenerate it. And I think that's what some of the suits are finding now, like the Getty Images case, for example. Through the prompts, they were able to reproduce images that look almost identical to images in the Getty Images database that were not allowed to be used for, for machine learning training purposes. Interestingly, they did have a paid version available. You could have licensed it for that, but the parties chose, not to. And then, is there a difference if the data is open source? I'd say, yes, depending on the terms of the license and, what it allows you, to do. Just because the software or the pictures are on the web, doesn't mean you can do whatever you want with it. The default is they're copyrighted, to the author. So in the absence of a license, you can't make a copy of it, even if it's there. Like you can't go, copy the New York Times and say, oh, I got it off the website, I'm going to, republish it over here. You need rights to do that. But that's, we're happy to dive in on these cases. I think they're going to focus a lot on that. And we have another comment. Oh, we'll add to the list, China AI regulations. Yeah, I think they're coming in China as well. All right, I'm just going to read the last set of the comments here. Okay, that's great. I think we hit all the questions and we got the poll results. So we'll work to figure out, what the next topics can be. And thanks to all of you for staying and sticking it out past time. And as Shane said, the recording will be made available, and we'll have the slides, I think, get included with the recording. Below the recording, we have bios and some other info in there, so those will be made available too. And we'll look forward to the next talk. And if any of your colleagues missed it because of the late start, let them know that the recording is available. So thanks to everyone, and we hope to see you again soon.